Okay, so now we have this series this power series, and right off the bat we can rewrite it as, let's see here, we can rewrite it as the sum of 1 over n times x to the n, and we can see that our center is going to be 0, and our coefficients are going to be 1 over n. Okay, now to find our radius of convergence and our endpoints, in fact, let's put those together. We're going to jump straight into, let's just use the ratio test again. Okay, so I need L to be equal to the ratio of consecutive terms. So I need x to the n plus 1 over n plus 1 divided by x to the n over n. Okay, then, ooh, that was quite incorrect. So L is equal to the limit as n goes to infinity of the absolute value of the ratio of consecutive terms. And so this is going to be equal to the limit as n goes to infinity. Now, let's see here. So I'll have x to the n plus 1 times n, and then x to the n times n plus 1, absolute value. And the x to the n cancels out, and the numerator and the denominator. I just get the limit as n goes to infinity, the absolute value of x times n over n plus 1. But I can bring out the absolute value of x times the limit, n goes to infinity, n over n plus 1. And this limit is equal to 1. So I can rewrite this as just the absolute value of x. So our series converges when absolute value of x is less than 1. It is diverges when the absolute value of x is greater than 1. And we have no conclusion when the absolute value of x is equal to 1. So in terms of a number line, our center is 0, and 1 and negative 1 are our endpoints. Put that in, plus and minus 1. And our radius of convergence is going to be 1. So we've got converge on the inside here, question mark at 1, question mark at negative 1, and diverge on the outside. Okay, so now it's time to test the endpoints. The endpoints are 1 and negative 1. So let's see here. So at x equals negative 1, what happens to our series? Our series is x to the n over n. This is going to equal negative 1 to the n over n. Does the series converge or diverge? It converges by the alternating series test. This is the alternating harmonic series, in fact. So the series converges at negative 1, so we can go here and update our graphic to say that it's going to converge. So C is included. And then we still don't know what's going to happen at 1, so let's just go and work on that now. So at x equals 1, our series, x to the n, our power series, is going to be equal to just 1 to the n over n, and that's just going to be 1 over n. Does this series converge or diverge? It diverges. It's the harmonic series. So it diverges by a p series with p equals 1. So this one is actually the harmonic series. Okay, so since it diverges, we can update to say that the series diverges, so it is not included in. So our interval of convergence is going to be -1 to 1, half open, half closed. So our interval of convergence is going to be -1 to 1, half open, half closed. And that's it. And we've got our radius is 1, and our center is 0.